Hi everyone, I welcome you to this video. So in this video, I'm going to be demonstrating how to design your pad footing by grouping similar column load together so as to make your design more economical and more efficient for the construction engineers to interpret without making mistakes. So what motivated me to make this video is because of some structural drawings I came about on site some few weeks ago. The part base were not much, but the part base type were too much simply because the structural engineer couldn't use his software very well, and he couldn't and he didn't want to use a manual design. So I'm using this medium to educate or to inform some of us that may not understand how to use the software to achieve that purpose. So the first thing we need to do is, after analyzing this whole exercise is just to show you how to design your pad footing by grouping similar column loads together so that they can be well grouped and well detailed for the construction engineer without making mistakes. Because when you have too much column bases in a project, there is a very large room for mistake. For example, when you have a column here 1 3 by 1 3, another column here 1 2 by 1 2, another column here 1 3 by 1 3, another column here 1 250 by 1 250, and having different column loads like that, column pad base like that, it will give the construction engineer some kind of headache, and it won't be even economical, because when you are calculating for the artisan that is going to make the form work, it's going to be calculating it one by one. Like, it won't be easy to group together. Okay, so that's the whole essence of this video. Okay, so the first thing you do before you can design a pad base in your analysis, you must have run your superstructure analysis and design, which I'm not going to show you how to do that in this, because I believe you should have known that, but in subsequent videos on these channels you can look out for that. So if you are new to this channel, kindly like and subscribe. Thank you. And you can also turn on notification to get notified when I drop a new video. Okay, so now let's continue. So the first thing you do when before you analyze your foundation is to go to your settings. I'm using ProtaStructure 2022 for this exercise. So go to setting center, is here at the top left corner of your screen. Sorry, you click on settings, wait for it to load. Okay, so you go to foundation, which is this, click on general. So soil unit weight, you can leave that as 18. Allowable soil stress, ultimate strength factor, all these things will be inside your soil test report. So here I can just assume some parameters. So our allowable stress of soil, let's use 200 kilonewton per meter square. Mind you, it is already in your soil test report. A soil test report is very important in every analysis you do, in every project analysis that you do. So your soil vertical subgrade coefficient, also you can also calculate it from your soil test report. So maybe I will be teaching you that in our next video. So let's move on. So after you set your parameters here, your soil, everything, your lean concrete is your blinding, you can set it to 50. Then your street foot, you can leave this as 1 meter. Then pad footing, you can change it to square, you can leave it as rectangular. So you can also change it later in the analysis, but let's just initially leave it as square. So the next thing, your design, 2% minimum steel, everything, just you can always leave all this like that. So your concrete cover, you can leave this as 50. Your concrete cover is different from your lean concrete thickness. Concrete cover is your cover to reinforcement, and we all know the meaning, we all know the reason for concrete cover. Why this part, this lean concrete thickness is different from this, because this one, it means blinding. Blinding is that weak concrete that we always put after your excavation, that lean weak concrete that we used to spread on the maybe your strip or your this thing before placing your cover blocks on it, then laying your reinforcement. So that is what your lean concrete thickness means. So after that, we can now go to still everything you can set as you desire, then click on OK. So after doing that, before you run your structural analysis, there is something you must have set, which I'm going to show you. I'm sorry. Okay. So there's something you must have set, which is your loading parameter, your loading combinations. So go to loading combinations. There are many ways you can get to this loading combination. Let me show you. The first way is by using this loading, then go to load cases and combinations. Another one is by going to analysis, which I just did a few moments ago. Okay, so now just click on loading and combinations. It's going to bring you this. Then go to loading generator. So this is your vertical loading combinations, and this is your horizontal loading combination. For your horizontal loading combination, if your building is not a high-rise building, so you can just use your notion. You can check your notional loading. What is notional loading? Your notional loading is just how do I explain? Okay, yeah, it's just like a vertical load, a lateral load that is used for how do I explain? It's just like a notional, like an horizontal loading that may be applied, like an accidental loading that may be applied on your structural members during construction stages. So that is what notional loading is all about. So it can be calculated by the percentage of the building weight itself. So that is the notional loading. So for your vertical loading, you just click on, you make sure that you create an unfactored G plus Q combination. This unfactored G plus Q combination is, this G means dead load or permanent load. For Eurocode users, G means permanent load, while for BS 8110 users, G means your dead load. Q for BS 8110 users, Q is your live load, while for Eurocode users, Q means variable load. So is the terminology that is different, but this thing is the same thing. So after checking everything, then just click on OK. But me, I don't want to reanalyze this structure. That's why I'm going to press cancel. But for your own, if you are testing this for the first time, just click on OK. Okay, so it's going to list all your loading combinations here. So this G plus Q1 here, as you can see, for this place there, the coefficient here means 1. The coefficient here too is 1. So this is our service load, which is our G plus Q without any factor. Why this one is G plus Q are, as you can see in this dead load G, we have 1.4. That is our dead load. We are using BSH 110. But for Eurocode, this your permanent loading, you are going to be seeing 1.35 here. While for Q, we are having 1.6 because we are using BSH 110. But for Eurocode users, you are going to be seeing 1.5. So that is, so etc, etc. So all these are just your loading combination. Some are when you have what's it called, a favorable GQ or unfavorable. So that is just all this coefficient. That is what they actually means. So that's all for that. Then click on OK. So now, since we have already done that, so now the next thing to do is go to it's not analysis, I'm coming, display. So after going to display, click on display setting. Is it this? Yeah, go to display. I'm sorry for this. Cancel. Go to visual interrogation. After going to display, go to visual interrogation. Then go to column display. Check axial load. Then come here. Click on dead load, live load. This is our service load. Why this one is our ultimate load. So click on OK and click OK. So as you can see, look at our plan now. This is our dead load. This is our live load. That is, this is our permanent load. This is our these are dead load, these are live load. I forgot the code terminology. Okay, so when you plus this, it must give you this. That is 295.1 plus 69.4. It must give you this service load. That is, this load plus this equals to this, which is the service load. While 1.4 times this plus 1.6 times this must give you this. So in your manual calculation, or if you use manual calculation to design pad footing, all you need is just this. Then you can just use this service load. You can use it to design your pad footing geometry, while you use this one to design your reinforcement. So that is it. So why do we use service load to design our pad base, our pad footing, what's it called, our pad footing geometry, that is our length, our breadth and depth? It is because we in the soil test, during the soil test, they have already used some amount of what's it called, factor of safety. So if we are now using another ultimate load to design for the pad footing geometry again, that is the size of our pad footing again, it will be like a very wasteful design. So that is why we use service load for our pad footing sizes. Okay, now so let's move on. So to avoid confusion in our grouping, we can just go back to visual interrogate. I just showed you that one so that in case you want to use manual design. So go to column display, then uncheck dead load and live load. Uncheck this also. Let's just leave the service load so that it can be easy to group. So now our combination one is live, our service load. So now let's say I want to group this column according to their loading. Let's say I want to group like from 100 to 200. We take the same pad base sizes. So I can just look out for any column with loading of lesser than 200 or lesser or equal to 200. So that is what I'm looking for right now. Or let me say 300, I mean. Okay, so I'm looking for 300 or lesser than 300. I could have chosen this, but I can't. Reason because if I do a separate pad footing for this and do another separate pad footing for this, they will be interfering, which is going to be causing, which is not the right thing to do. So I can combine these two together and make it a combined footing pad based on its own. So now I will leave that alone. So this one is 114. I'll choose this. This is 550. I can't choose this. This and this and this can be combined together. So this one is 109. So just press Ctrl. Since you have chosen one here, press Ctrl, you hold it down and click another one so that you can, as you can see. So that's it. The control is on your keyboard. Just press Ctrl on your keyboard and click on whatever you want to click. Which one is this? 152. Click on this also. This one can be combined together. This is 103. 153. Combine this together. 199. I can combine. I can choose this two. Which other one? I can choose this to 154. I can combine this. This is 225. I can choose this. It's not up to 300. This is 206. I can choose this. This is 235, 216. I can choose all this. I can't choose this. I can't choose this. Okay, so since we've chosen the ones, then the ones lesser than 300 kilonewton. So just right click and click on insert pad footing. Okay, so after inserting after loading this dialog box for you, so just click on one of them and press Ctrl A, select all, then click on group selected. So it's going to group everything. So anything you change is going to change for everything. So now you can now double click on it to bring out the interrogated design. So I think I've double clicked it. Yes. Okay, let's wait for it. I'm sorry. Sorry, why is it slow? Okay, these are the columns we chose. We chose 1C22, 1C27, 1C26, 1C32, etc., etc. So, oh god, what's happening? Okay, thank god. So it has already designed it as 12 by 13 by 300. We can actually force a square design. Then should okay, if you choose 12 by 12, it won't work. So let's increase it to 13 by 13. So 13 by 13 works. So we can always now change other parameters as we like. So I'm not going into that today. Thank you. So that's this for the first one. So now click OK, and it has designed. We are using T12 at both ways. So let's wait for it. So as you can see, this is part-based type. This is another part-based type like this. If you choose one of these, everything is going to be selected. So that is a type part-based. So initially, if you were to design all by each of their this thing, we are going to have too many types of part-based, which will not be okay. So some people even they just go and check for which column is more critical and use that column to design for everything, which is also very wasteful. It is not ideal. It is not an ideal design. So it has already defeated the purpose of design by doing that. Okay, so now let's move to next set of column load. Let's say we are using column after column 0 to 300. Now let's go to column 300 to 600. Okay, so now 600. Let's go to column 300 to 500. Sorry. Okay, so this is 500. We can use this. This is also lesser than 500, lesser than 500, lesser than 500. Okay, so all these are as greater than 500. Lesser than 500, lesser than 500, lesser. So you know when you are clicking on it, you have to hold your control on your keyboard so that you can be selecting them appropriately, efficiently. So that's it. I think that okay, this is 450, lesser than 500. So you can cross check again so I won't leave anyone behind. This is 300, this is 493. Okay, I think we are good to go. Okay. Alright, yeah. So now right click again. Right click on insert part footing. So after bringing this dialog box, then just click on anyone, press Ctrl A to select all, then click on group selected. It has grouped it, then double click on it to design it. So it's going to be somehow slower here. I open so many things. This is AutoCAD 2024, Revit 2024, Prota 2022, and even Google Code, which is I don't think. Okay, so should be faster now. I don't know. Okay. Alright, so it has already designed it to its own this thing. You can always check. Okay, I think by 400 is better, or you can then click on OK. So this is 18 by 400. So that is that for that. So if you choose one of these, everything is going to be highlighted. Can you see? If you choose it, everything will be selected. So that is it. We only have two part-based type now. Part-based type 1, part-based type 2. Now, if you want to design this also, you can now choose another column load this thing, maybe from 500 to 800. Then you select all those ones again, or 500 to 900. So whichever way you want to do it. So that is how to let me design a combined footing for you also, so that you can understand. If you want to design a quad footing, just press Control, select all the column you want to put on a single part base. These two, I want to put them on a single part base. So double click, click on the two, select them, then right click on it, click on group, I don't know, where is it? Insert, as you can see, insert combined part footing. Click on it. So this is the combined part footing, which is 2-1 by 2-1 by by 400. So just click OK. Okay, so whichever way you want to design your this thing. So that is how to design effectively without wasting resources and without, so that's it. Thank you for watching this video. So look out for more exciting videos on this channel. Thank you. My name is Olayin Kansho Remekun.